Hi, this is Jeff with Sabe. This is the first of 2 or 3 videos where we will explain Sabe support for buffer management and DDMRP. So I'm logged into Sabe with our bike demo database. I have a diagram right here of the relationships that we'll be talking about. We have an item in a site makes an item site. So this is actually a configured bike. We have sites manufacturing, retail north, and retail south. Once we put that bike into a site, we generate an item site. An item site is the entity where we define stock levels and buffer levels and such. And the item is the engineering definition of a part. So I have this bike in the manufacturing item site, the retail north item site, and the retail south item site. Once an item has been placed in an item site, we assign a planning policy to it. The planning policy defines the replenishment strategy. So in this demonstration, we'll show that the planning policies for these item sites is a buffer managed DDMRP replenishment policy. However, we can have multiple planning policies. We see that the retail item sites are managed by a retail planning policy, and the MFG item sites managed by a MFG planning policy. Planning policies belong to planning categories. Similar planning policies belong to the same planning category. DDMRP defines the concept of buffer profile families, and we'll see how a buffer profile family consists of multiple planning policies under a given planning category in Sabe. So from here, we're going to take a quick look at some of the data to get some background. Firstly, we'll take a look at the item. And again, because Sabe is fully multi-site and we can support instances that have a single site where we do manufacturing and distribution out of the same site, or instances where we have a manufacturing site or multiple manufacturing sites and multiple distribution sites and perhaps hundreds of retail sites. We make a strong definition or a strong separation between the definition of an item and the definition of an item at a site. So here we have this configured item. It's a mountain bike. If I view the item, we see that this item belongs to 3 different sites: manufacturing, retail north, and retail south. If I view one of these item sites, site manufacturing is assigned to planning policy MFG. So you can see that the buffer management definitions are layered in along with everything else, with material codes and cost categories and ABC classes. DDMRP is a first class entity in Sabe, and its support is equal to that of any other replenishment policy, pegged MRP or min-max or what have you. So in the same way, we have the manufacturing site for this part managed with a planning policy called MFG. We have a similar situation for retail north, planning policy retail, and retail south, planning policy retail. So once we have the items and the item site set up, we can take a look at the planning policies to which these items are assigned, or item sites rather are assigned. Now, again, Sabe supports many, many different planning policies, and those planning policies can be related in families, which we'll talk about shortly. In this case, we have a manufacturing planning policy, which has the one item, which is the bike that we're looking at in the manufacturing warehouse. So it's this planning policy. We are buffer planned. We are not demand planned, so we're not using MRP's replenishment policies. We're considering demand spikes, so this kind of defines that we're using a DDMRP defined planning policy. In Sabe, we can support ADU factor buffers and LTU factor buffers. So in this case, you can see that we have a green zone set to 10 days of average daily usage, a yellow zone set to 0 days of average daily usage, but including the item site lead time. So this means that the yellow zone is 100% lead time usage, and the red zone is two plant sigmas or 2 sigmas. Optionally, you may also use LTU factor buffers, and this is the more traditional percentage of lead time usage that we find in the DDMRP specification. So that's our manufacturing planning category, and our retail planning category is set up very similarly. buffer plan demand, or I'm sorry, buffer plan. We're using spike. We've set the demand threshold just a little bit higher, and we're using 5 days of ADU instead of 10 days of ADU for faster throughput or faster replenishment. You'll notice that this planning policy belongs to the retail planning category, while the MFG planning policy belongs to the MFG planning category. So again, a planning policy must belong to a planning category. A planning category can maintain or be assigned to more than one planning policy, which would be the buffer profile families that we're talking about. So if I take a look at planning categories for MFG, here's where we define the analytic period, which is the number of days back in inventory history Sabe will look to determine the average daily usage. So we're looking back in inventory history 180 shop days, not calendar days necessarily, but shop days, to determine usage history. The analytic resolution is the size of the bucket into which all of that inventory history we placed to determine the standard deviation. We've set, because our replenishment policy is based, our yellow zone is based on one time 100% of the LTU, we're going to set our analytic resolution to the same. So we're going to set our sigma calculation to determine unrepeatability of consumption during the reorder period, during 100% of LTU. Now, this planning category is DDMRP managed. We'll talk about that in a little bit. We have buffer profile definitions. If a planning category is DDMRP managed, the items to all planning policies which are assigned to this planning category are subject to reassignment based upon the buffer profile definitions. So the DDMRP specification talks about short, medium, and long lead time, and talks about low, medium, and high variability in consumption. So that reassignment is defined by these buffer profile definitions. So what I can do is I can say that low variability is defined by 22nd percentile, the lower 22nd percentile of total variability for all items in all planning policies that belong to this planning category. High variability is, let's say, 78%. Now we have a tool, which we'll show a little bit later, which actually uses these values and will reassign all items that belong to this family of buffer profiles to the appropriate sibling within that family. Now, it's a little complicated. It may sound a little complicated. When we use the tool, it'll actually make a lot more sense. So I think we're ready to wrap up this first video. Again, we have planning policies, MFG with one item, and I can see our item site. I can see that item site here. It's my finished bike in the MFG site. So it's this part in this site. And we have two items in our retail planning policy, which are the same bike in retail north and retail south, which is this part in these two sites that belong to this planning policy. Now, one thing I want to point out is because we haven't defined the actual sizes of the buffers yet, you'll see the constraint status they're all empty, they're blank, meaning that there are no buffer profiles or buffer definitions that are applied to these item sites yet. In the next video, we will use the master data we've just set up to create planning parameters, to execute replenishment strategies, and to execute those replenishment strategies to actually create operational work orders, transfer orders, and purchase orders. So stay tuned. We'll be posting that video shortly.